Can we give it a go?
Yeah, go ahead.
Yeah. So before I do start, a little bit about. Actually, I'm closer to the button, so I may sit for a little bit. But I poke around on the screen too. So a little bit about myself. I'm a retired water engineer, hydrologist, and I received climate reality leadership training about 3 years ago. And so I'm not an expert. I'm a concerned citizen. And part of that training is that you pass the information forward. But I'm also a fortunate grandfather, and that's Jack, our grandson, who's now just about 3, and then Ruthie was born about 3 months ago. So I'm a lucky grandfather. But you'll see them a little bit later. So it's arranged where going to pass the training forward, but then at the end, I'd like to interact and ask some questions of you and kind of learn from you guys. So it's arranged 3 ways. 1, do we need to change? And then, can we change? And then, will we change? And this is a shot looking back from the moon of Earth, and it was during the Apollo program years back. And
Isn't that beautiful?
it is, and for me, when I look at it, it shows really how finite Earth is, just how beautiful it is. So, a little bit of science. We receive radiation from the sun, heat, and about 50% of it, 50% of the heat is taken in by Earth. About 25% goes out to space, and 25 gets trapped in our atmosphere. And that's been going on for millions of years, where this heat gets trapped, and we've got carbon dioxide in that layer. But since about World War II, we've been putting extra carbon in the atmosphere so that this layer is holding a lot more heat since about World War II. So again, sunlight comes in, 50% is sorbed by the Earth, 25 goes out, 25 gets trapped in our atmosphere. But that number's been going up because of the carbon we've been putting in.
Can we ask you a question?
Sure.
Because you didn't say the water, the oceans, isn't that trapping heat too?
It's trapping carbon, and I'm going to get to that.
Okay.
What oceans do, very much so. It's important.
That's what I was wondering.
So we're using our atmosphere kind of like an open sewer, and it's really not that thick. That's a shot of our atmosphere. At highway speeds, you would drive through it in 5 to 8 minutes. It's just not that thick of a layer. And this extra carbon we're putting in the atmosphere, where's it coming from? Well, it's underground. It's the coal, it's the oil, it's the natural gas that's underground that we use in our day-to-day lives. So that carbon we're putting up there has been underground for millions of years. So this is a graph in time. This is back before the Civil War. And this is global using of fossil fuels, of coal, natural gas, oil. And you see how it shoots up after about World War II. You see a little downtick here? That was during COVID. So globally, we used less fossil fuels during COVID. And what makes up this fossil fuel? Maybe about a third is coal, a third is crude oil, and a little bit less than a third is natural gas or methane. So I'm going to go through some of these slides kind of fast because there's a lot of stuff I want to show you in 40 minutes so that we have time to talk. But these next 2 slides I'm going to spend some time on because they're important, I think. This axis is time. So this is 10,000 years ago. The last ice age ended about 11,000 years ago, back here. About 6,000 years ago, we started coming together with villages, civilization. So this is time. And over here, this is the concentration of carbon dioxide in our atmosphere. And you can measure that as easily as you can measure temperature or oxygen. It's an easy thing to measure. And if you look back to the last ice age, naturally carbon dioxide went up and down. It goes up when you have volcanoes going off. It goes down when you have more vegetation on Earth, because plants use carbon dioxide. So when it goes down, we had a lot of plants on Earth. So you see it go up and down naturally, right? This is since World War II. So it naturally goes up and down maybe about 200, this is 270, 280, 270, 280. Since World War II, we shot up to 420. So I'm going to blow this period up, and just keep in mind how carbon dioxide was about 270 to 290, and look at the yellow line. So here's the yellow line. This is before the Civil War, and this is carbon dioxide, from about 280 to 420. Okay, this is carbon dioxide, it's yellow. The other information that's on here is temperature of the globe. And this is weather. Some years are warmer, some years are colder. But look at how the trend follows. The weather, the climate gets warmer with carbon dioxide. And that's because, the Earth's a complicated system, but if you take 2 bottles, you can do this in your kitchen. Take 2 bottles. One bottle, take the air from the room. The other bottle, take carbon dioxide, put a thermometer in each one, put a heat lamp on it, and the bottle with the carbon dioxide will heat up faster and stay warmer. So carbon dioxide is this insulator that we've been adding since World War II. So when you do have that extra insulation up there, it heats up the globe. And if you take the average global temperature since about the Civil War, the average, which years were cooler? These years were cooler here. Which years were warmer? It's a pretty clear pattern, and this was last year actually. So we have heat waves around the U.S. In Europe, they've had heat waves in record temperatures in those countries. And who's most vulnerable? The poor, elderly, young people, people with existing medical conditions, mentally ill, and folks that work outdoors, right? Farmers, folks like that. And like what you said, we're trapping this extra carbon and so extra heat. A lot of that heat goes into oceans. And if you do that same, if you take the average ocean temperature in the last 60 years, which years were cooler? These were cooler. These years were warmer. So it's a pretty clear pattern. And one of the things that happens when you have warmer oceans is you get stronger hurricanes. I don't know that you get more hurricanes, but you get stronger. So when Hurricane Ida went up there in the Gulf Coast was about 7 degrees higher than normal. It was a very strong hurricane, went up the coast of the U.S., over 80 people died. And I think, we're familiar with these pictures, of damage. And hurricanes can drop a lot of water. Harvey dropped 5 feet in Texas. And last year, if you took the major ocean basins, last year was the first time that they've had a Category 5, a really strong wind in all of the basins in the same year. And one of the things that when you have these extreme events and you have releases or damages to industrial areas, a lot of the chemical releases, they're in lower income neighborhoods, they're not in high income neighborhoods. So it's the lower income folks, minorities that pay the price. So there's a lot of damage to our infrastructure. I'm not going to talk about all of this. Here's just a shot of damaged roadway after a flood. But it costs us a lot of money. In the U.S., $1 trillion over the last 7 years, and those are costs that we all pay for, right? And the cost wouldn't be there if we weren't using fossil fuels, coal, oil, natural gas the way we are. And globally, it's also a lot of money globally from extreme weather. And as you have more heat trapped, you evaporate more water. So you evaporate more water from the oceans, and you end up with these, the weather folks talk about atmospheric rivers. And atmospheric rivers just concentrate in the area, in the atmosphere. So here you see this, all this moisture approaching California. This is a clip from NOAA. And so you have really extreme downpours, and for every 1 degree warmer, or that's 1.7 degrees Fahrenheit warmer, you can hold more water in our atmosphere. So right now, our atmosphere has got 5 to 15% more water up there than there was 50 years ago. So there's more water held up in the atmosphere. And this was floods in California from these atmospheric rivers, and flooding in the Midwest, and it's overseas also. It's just not happening in the U.S. This is in Italy. So some years back with the U.S. Geological Survey, I was on a temporary assignment to measure floodwaters on the Red River. We were measuring the amount of cubic feet per second, or gallons per minute, going under bridges and around bridges. And
Is this the Red River, Minnesota?
it was in
Texas.
Dakotas.
Dakotas.
Yeah, right. Red
Dakotas,
River.
I'm sorry.
Yeah, and I mean, I saw I grew up on a small farm outside of Manitowoc, but I saw a farm that all you saw was the tip of the barn. It was amazing, And so the flooding, affects agriculture. And this same extra heat that pulls water from the oceans, it takes more water from the land too. So you end up with longer and deeper droughts. I mean, this was the Platte River in Nebraska, and the American Southwest has had some of the driest 20 years in over 1,000 years, and it's also, this is China's feeling it. I mean, again, this isn't just happening in the U.S. The globe is feeling it.
Aren't some deserts turning green?
I don't know that they'd be turning green. I tell you what, I will talk a little bit about in another part how the effect isn't the same around the globe. Some areas are going to get more water, some are going to get less. It does vary, and I'll talk about that a little bit later. For every 1.7 degrees Fahrenheit warming, you have more lightning strikes. So every 1 degree Celsius, you get 10% so more lightning. So California had 14,000 lightning strikes, which was in 900 fires, and this is a map of the Canadian fires last summer. And, in the Midwest here, we sometimes kind of think, well, all this bad stuff's going to happen someplace else, right? We're good here, right? Got some tornadoes, but I felt the effects of this last summer. So Canadian fires last June. We live in Madison, and this is a picture close to our house of the Capitol across Lake Monona. So notice this bench, and this is a sunny day. This is a sunny day a few days later. Notice that bench. There's that same bench on site. You can't see the Capitol because of smoke from Canada. And I have to confess that I wasn't, they were having health hazard, don't go outside without a mask or anything. I was kind of blowing off the mask thing. And Amy was saying,
Mask.
well, then I saw a paper that said that, and this is relatively new research, it takes the medical community a while to understand this stuff, but that the longer the smoke is in the air subjected to solar radiation, the more detrimental it is getting into your body, in the cells. I'm not talking about your lungs now, but they react with the sunlight and they can enter your cells. So I was wearing my mask, anyway, and I have this slide in because you got people playing golf, you got these fires going in the background. We can't accept this to be the norm, right? And I mean, some of this doom and gloom is not easy to sit through, but give me 5 more minutes of doom, and I'll talk about how we can fix this. And we're not doomed, but just 5 more minutes of the effects of this extra carbon that's up here. So we've affected the hydrologic cycle, how we evaporate water, how water comes down. And Department of Defense has said that climate's gonna be leading to refugees, disease, some shortages, and globally, there's a lot of people on the move because of extreme weather, and this is a shot of Syrian refugees in Croatia in 2015. And I was in Croatia in 2015 on a train. The situation was about a third of that. The police had it under control. And I thought, these are Syrian refugees because of the political situation in Syria. But it turns out they've lost over 50% of their farms to a drought. And a lot of them are moving on because of the extreme drought that they've had. So it's not quite as simple as saying, hey, it's a political situation. A little bit more science. So a 1 degree change at the equator gets magnified to 3 degrees at the pole. And this temperature movement sets up currents in the air and the ocean, which are important. When I was in the Coast Guard down in Miami, I was in the Coast Guard. You've got the Gulf Stream, which comes up along Florida, coast of the US, goes over and affects the climate in Europe. And scientists don't have a good handle on at what point these currents will change due to higher temperatures going in. Also, the higher temperatures are melting the ice. I have a couple slides with that. But what scientists don't know is at what point that these currents may change. And that's called a tipping point. A tipping point, if you hear that, is nothing more than something that changes rapidly. You can kind of think of ice, right? It's solid, 20, 29, 30, 31, 32, it changes rapidly. So when you hear climate tipping point, these currents are one where they think it may change quickly. You hear a tipping point of these peat bogs or of coral reefs. A little bit of ice slides. This shows ice in Greenland back in 1935, and you can see it's really recessed back in more recent years, and this is just a drop off of the ice mass in Greenland consistent to current. At the North Pole, you see the ice mass go up and down historically for 1,500 years, and then since World War II, you see it drop down. Same thing at the South Pole. And I have this in because about 10 years ago, I was in Peru, and I was in a small village, and they lived off their local farming. And to irrigate their crops, they use snowpack melt in the summer, and then normally in the winter, the snowpack would come back. It was almost gone for them when I was there, and they didn't have another alternative. In other words, when they couldn't irrigate, I don't know what they were going to do, and that's one example of how people have to move on. So it affects people around the globe different ways. I had this shot in because I was on a buoy tender icebreaker in Sturgeon Bay. We're coming back from an ice patrol, and being on a steel-hulled ship is really noisy. So we turn the engines off, and here the crew has got to pull the ship down. I'm kidding. It's a joke photograph. We did have the crew go out. We just took a picture of it, but they're obviously not going to pull the ship through the ice. But we just had some fun on the ice. But ice is needed at the poles for the ecosystem and the animals, but I have this shot in because it's just plain beautiful. That's some pancake ice off the bridge of the ship coming from the Sturgeon Bay Ship Canal.
And
So-
doesn't the ice on the poles reflect some of the sun's heat? It's
Exactly
kind
right.
of a feedback loop?
Yep, it is a feedback loop. You're exactly right. You're exactly right. And with the melting of the water that's kept at the poles, the oceans are rising and they will rise. And this just shows a list of the cities at risk, and you can see New York and Miami are right there. And Kiribati is a South Pacific nation that had to purchase land to move some of their folks because of rising seas. So again, it affects people around the globe different ways. The Pope has said some of the toughest effects of the environment and climate are really suffered by people who can have the least ability to do something about it, the poorest around the globe. And the Lancet is a a medical journal that said, climate, the climate effects are going to be a health threat, this century. I'm not going to go into all of these. We've talked. This is how health is affected by climate. We've talked about extreme events and heat stress. I'm going to talk about air pollution just a little bit because, globally, 9 million people die a year due to air pollution. And here in the U.S., through the training supplied me with a fair amount of these slides, and for each of these slides, I've got the reference for the scientific journal and business. There are references for each of these slides if you're curious about it. But that in the U.S., over 20 years, we had just under 500,000 early deaths from, particularly from coal plants. And in East Asia, 3 in 10 deaths are due to fossil fuel pollution. And coal plants are kind of a triple whammy. One is they're taking carbon, coal, that's been down there for millions of years, they're burning it and they're putting it in the atmosphere. That's one. Number two, even with the scrubber, they release particulate, which affects their health. And then third, mercury is attached to coal. So when they burn coal, mercury goes up in the atmosphere, and then it comes down on land and water. And I had a colleague at the USGS, Dr. Dave Krabanoff, his team, he spent his career understanding and looking at mercury in U.S. rivers, lakes, the Yukon. And I think, so mercury in the oceans has gone up. And I think most of us know that women of childbearing years and young children, you gotta be aware of the fish you eat. So the cost of carbon is high, and it's a cost that I don't want to put onto our adult children and our grandchildren. And the Earth is not a simple system, but it helps me to think about, you can do this simple experiment in your kitchen and see that carbon dioxide is this insulator. So, must we change? Yes, and here's the good news. We're not at all doomed. We've got the solutions in hand. We just need to want to do it. And it used to be felt up until about 4 years ago that, let's say right now we leveled off the amount of carbon we're putting up there. It used to be felt that it was going to keep getting warmer for like 25 to 30 years. But over the last 4 years or so, the scientific community has found that if we can level off what we're putting in the atmosphere, the effects can be stopped in 3 to 5 years, and that's because they now understand that the oceans can take up a lot more carbon than they thought, and the Earth's vegetation. They can sequester more carbon. So we can turn this around quickly. So how are we going to do it? Well, one way is wind. It was felt back in 2000 that we would grow 30 gigawatts by 2010, grow by 30. Well, that was exceeded in 20 years by 31 times. So the cost of wind has really gone down over time. So we've got a lot more wind capacity, and we're producing a lot more power with wind. Germany 4 years ago produced over 50% of the electricity from wind and solar. China is making a huge amount of wind power here. You see them with one of the arms from a wind turbine. And our hometown in Manitowoc is producing the columns for these turbines that you hear. They're manufacturing those. China's still burning coal, but they're trying to phase it back. I mean, they know what the deal is, and it's felt that their emissions may peak as early as next year. And wind could supply 40 times the electricity that we need globally, but it doesn't always blow, right? So wind doesn't always blow. Another is solar. It used to be felt around the year 2000 that we'd grow 1 gigawatt over the next 10 years. Well, that was surpassed by 17 times, and right now, we've exceeded by over 440 times. So solar, the cost of solar, that's the cost of a solar panel back in 1976 and what it is now. The cost of solar panels have really come down. So we've got a lot more, solar installations. There's a lot more solar here in the U.S. But it's not just in the U.S. Australia, 1 in 5 houses have solar. The Vatican is going to be one of the first sovereign countries to be net zero with carbon, and they use a lot of solar panels. And internationally, there's some coordination. This area of Africa has got a lot of solar, and they're looking at putting a cable in and moving that power to Great Britain. And solar panels work well in Minnesota and Wisconsin. When I get done here, we've got panels on our house that I'd be happy to tell you about our experience. A little shot here of mixing solar with farming. Up in here in this corner, you've got sheep grazing between the panels. Here you've got a livestock shed covered with panels. Here you've got crops between them. And the University of Wisconsin is researching which crops grow best between the panels, because you've got some shading. And this is solar panels. These are solar panels between a freeway, and I think that's in Korea, actually. And if you take all of the Earth's energy needs for a year, all of our energy needs for a year, we have that much solar every hour. So we've got a lot of solar coming down. But again, it doesn't always shine everywhere. So you need to store it. And this was from Forbes magazine, I think. This is the ability to store electricity. And this is where we are now. And this is the anticipation of the next 25 years. This is a battery storage plant, a huge plant. It used to be a natural gas power plant. But now it's the largest storage plant in the world. And actually, this slide's a little old. I think there are larger ones. Because you need to store it you may have to store it from the summer to winter, because here in our part of the country, like right now at our house, we're producing a lot more electricity than we use by day. So we're actually sending it back into the grid. But in the winter time, we don't produce as much. Days are shorter, sun is lower, So may have to store this power for months at a time. The University of Wisconsin is working with Alliant Energy with this way to store energy. They're compressing gas. So what they do is you take electricity that's produced from wind or solar, take that electricity, compress a gas, in this case it's carbon dioxide, compress it down, and then when you need electricity, you expand it back up to run the turbine. So compressing a gas is one way to do it. And they're also looking at other ways to store energy. Whether it's thermal, heating up sand or salt, or liquid hydrogen. I'll talk about that a little bit later. So there were a couple things about the training that really surprised the heck out of me. And this is one of them. To produce electricity from coal, this is the cost the last 10 years. So it was pretty constant. Making electricity from coal stayed pretty constant. Natural gas got cheaper. And you hear it talk sometimes that natural gas is the clean alternative. That's partially true, because natural gas doesn't have that particulate that coal does, right? But natural gas, which is methane, which is CH4, it takes carbon that's been underground for millions of years, it burns it, and puts the carbon up here. So it's not helping us as far as climate change. The cost of nuclear has gone up a little bit. There's a couple reasons for that. But the cost of wind has gone down. And the cost of solar has really come down, so that if you're managing a power company and you need to have 25% more power, it's just cheaper right now to get that extra power from wind and solar, which is huge.
But is that due to government subsidies?
No, and actually, coal and natural gas are subsidized also. So even without subsidies, they're cheaper. And this quote was from a CEO of a power company, and it was that his surprise was that renewables, wind and solar, and the storage beat natural gas. He wouldn't have predicted that. And the coal miners didn't bring this on, but they can be retrained in wind and solar, and it'll be a safer job. I mean, the Massey coal mine accident killed 29 workers. I've got this slide in because going to renewables will be safer for the planet. Our son was in the Coast Guard, and he was sent down for the Deepwater Horizon spill years back where that platform exploded, and Casey was sent down there to work on it. He was saying how much of a nightmare it was to try and contain or clean up the 3 million barrels of oil. And again, 11 lives were lost on that platform explosion. And right now in the U.S., there are 10 times more jobs in wind and solar than coal mining, and the mining union has recognized that, and that retraining will take place. China is putting in more solar than Australia and the U.S. combined. Vietnam, their capacity grew by 100 times in 2 years. And there are a lot of global jobs in renewable. Another part of the training I hadn't realized was, and if you want to call it social justice or energy justice, but people around the globe are going to have access to power now that didn't have it before. They weren't in countries that were stable enough to have, they didn't have the utilities, but it doesn't take much to put up a panel and a marine battery that produce power for your water pump, your refrigerator, your lights, your computer. It doesn't take infrastructure to do that. This is just a shot of some portable panels in Sierra Leone. So globally, a lot of companies have pledged to go renewable. This is just a slide of a bunch of those companies. And auto manufacturers, they see the demand for electric cars, and they're producing electric cars. You know, General Motors has said that in 11 years, they're not going to produce gas or diesel passenger vehicles anymore. And Volvo's made in Sweden. In 6 more years, all their vehicles will be electric. And you know, it helped me to think about, you know, in this country, it took us 20 years to go from horse transportation to cars. In other countries, it took longer. But, you know, and you think about the changes that must have happened to make that happen, roadways and eventually filling stations. You know, we can do this. And, you know, batteries need to get better. So the cars have got a better range so you can charge them faster. But Harvard Engineering is researching solid-state batteries which charge in minutes, and Honda's looking to use solid-state by, you know, in 6 more years. Tesla is looking at trucks that go to 300 to 500 mile range on a charge it. A lot of countries around the globe are looking to phase out gas and diesel. You know, Norway's just about there. One state, California, in 11 years, they're going to start phasing out the electric vehicles in 11 years. And Norway is just about there with their cars, and you know, their capital's air is noticeably cleaner, and they didn't have a disaster with unemployment at gas stations or auto mechanics, and it didn't strain their electrical grid. And you know, Norway is a smaller country than us, right? So our problems aren't going to be the same, but we certainly can certainly learn from them. So a couple of additional solutions. One is agriculture. I don't know, either of you involved in farming, relatives, farmers, or Yeah, farming is going to be really important, and I don't know that much about regenerative agriculture. I know a little bit, but like crop rotation, low-till cover crops, rotational grazing, agriculture is going to be a big deal because if you think about it, just crudely think about it, the longer you can keep green on the soil, the more CO2 it's pulling out. So farming is going to be a big deal. This is a steel mill in Sweden, making steel since 1600s. They're now using green hydrogen. What's green hydrogen? Green hydrogen is you take electricity from a wind turbine or solar or a water dam. You take that electricity and you apply it to water, electrolysis, water, H2O, right? Electricity to water, you apply it to H2O, you separate off the hydrogen and you store the hydrogen. So that later, when the sun's not shining or the wind's not blowing, you can use that hydrogen to burn and run a turbine. Or in this case, they're using the hydrogen in an industrial process. And hydrogen is also, when you hear about a fuel cell car, that's what you're burning, hydrogen. When you put hydrogen and oxygen back together, you get electricity and you get water out your tailpipe.
I was going to ask if there's a byproduct to burning hydrogen.
No, so, well, for electricity, now, not in the industrial, but if you're going to use it like in the fuel cell in a car, you literally take hydrogen that's stored, combine it with oxygen. There's a catalytic material, I don't know what it is, that allows them to come together. But you have hydrogen, you have oxygen from the air, they come together, you get electricity to run your car, and you get water out your tailpipe. Using hydrogen in a factory, you would be releasing hydrogen off, I think, but there's no carbon, so it's not a greenhouse gas result when you
They were thinking of this many years ago with the hydrogen in cars.
for sure, for sure. And in
it's
some
very
parts,
disappointing that they were squashed.
yeah, some parts of the country you see them a little bit yet, but you're right, it's been around for a while. And actually, I don't want to get too goofy, but the development of the car years back, when the car was first developing, the electric car was really popular then, and you had the combustible. And it was kind of a flip which way they were going to go, electric or combustible. And a part of it, and you're taping this, but I'm still going to say it. Part of it was they went combustible because the guys liked the roar.
Yep.
And that was part of the effect. They liked the roar of it. The electric cars really were worked really well, but it was kind of a toss-up which way we were going to go, but we went that way. So Sweden now, nationwide, uses a tenth less carbon to produce electricity for their people. A tenth less than the rest of the globe, I should say. They have really reduced their carbon, and in Sweden, for those times when the sun's not shining, the wind's not blowing, those gaps, they're using nuclear, But they are using a tenth less carbon than the rest of the world, and their economy expanded 50%, and they've got healthier air. Uruguay is another country, nationwide. They've gone to almost using net zero carbon. They use hydro to fill in their gaps. So there's going to be different ways to fill in the gaps. Another part of the training I hadn't thought about, but it's hopeful to me, was this. If you look at the big picture, the agricultural revolution, where we went from being hunter-gatherers to growing food, that took about 600 to 800 years. It took a long time. The industrial revolution, where we used the power-driven machinery, that took about 80 years, from, 1760 to 1840, something like that. 80 years. So 600 to 800, 80 years. The digital revolution has been in our lifetimes. That's been really fast. And it's felt that the sustainability economy that's around zero emission can be done really fast because it's going to be built off the digital revolution. So can we change? For sure. We really have what we need right now But will we change? That's the question. And one reason that I'm optimistic that we can do it is under our free enterprise system right now, it's just cheaper, the wind and the solar, than coal, natural gas. So will we change? Well, you know, the Paris Accord was almost 10 years ago, and nations came around to achieve net zero by 2050. And 80% of what's being put up in the atmosphere are by nations that have signed on and set a net zero target. And the Inflation Reduction Act passed in this country deals a lot with carbon and reducing greenhouse gas. And since the Inflation Reduction Act was enacted, we've got, you know, over 40,000 jobs. And it's not just in the US. Australia has passed legislation. And on a local effect, a fair amount of municipalities have pledged to go renewable, and some have achieved it already. But we have to do this quick. And have we ever done anything quick like this before? Well, back in 1980, AT&T wanted to know how many cell phones are we going to have in 20 years. So they projected just under 1 million. They are off by over 100 times. The actual cell phones were over 100 million phones. And right now, it's 100 times more than that. There are 10 billion cell phone connections. So they weren't just wrong, but they were really wrong. And the question is why? Well, the cost of a cell phone dropped sharply. And the cost of solar panels, they've really dropped. And the quality of cell phones got a lot better, and the efficiency and quality of solar panels have really gotten better. And you know, in countries that didn't have, again, the stable government, the utility to produce phones, they didn't have the landline capability because of the wires. They leapfrogged it such that this is the amount of cell phones since 1990, the last 30 years. So this is the developed country, and that's the undeveloped world. So, you know, it's felt that solar panels can be similar because it doesn't take a big infrastructure to use a panel. You put a panel up and you've got a battery to store it. You know, here's a shot of some panels in a village in South Africa. So a lot of these slides were from training I made. Some of them, obviously, the training didn't give me the goofy one of people pulling the ship in ice, and so I made some of these myself. But I made this one on Time Magazine. Said, year of 2022 be the year that people and organizations and governments started to come together. So starting to make electric cars. Offshore wind is getting big in Europe and China, and we're starting to use it in the US, and Iceland is looking at a way to pull carbon out of the atmosphere. Batteries are really changing. Coal is being phased out around the globe. This one here is interesting to me, that scientists now are understanding the cause and effect much better. So in other words, the calculations of the chemistry and physics are getting very good, so that if the scientists look at the year 2000 to now, and they look at the amount of solar radiation coming down, the amount of greenhouse gases we're putting up, they can predict not just a trend line, how it's getting warmer in certain areas of the globe, they can spatially predict. In other words, their calculations can show that this portion of Africa is going to be drier, this portion is going to be wetter, this portion is going to have heavier rainstorms. They can't do it on the scale of how's it going to be different in Cannon Falls versus Madison, Wisconsin. You know, they don't have it on that scale. But their predictions, so that if they did that calculation from 2000 to now and predicted for what it was like last year or the year before, they're pretty darn accurate. So the science is getting better and better. So the point is, when they say that we need to do something to keep our global average under 2 degrees Celsius to prevent these kind of events and all, we need to pay attention. And as far as people coming together, back September, I was at a get-together at the University of Wisconsin where they interviewed Paul Ryan, the former Speaker of the House, and he said, let me say for the record, it's good to get carbon out of the atmosphere. So you've got people across the political spectrum realizing that we've got to do something about the atmosphere. Now he had said he's not in agreement exactly how the Inflation Reduction Act does it. He would do it a different way, and he talked about that a little bit. But you've got folks like that are saying we need to get carbon out of the atmosphere. So young people across the world are saying, hey, we want safer jobs, we want a cleaner earth, and so we've come to a decision point. We can fix the climate, and we've got heat waves, we've got strong hurricanes, we've got droughts, and we have the solutions to fix it. Right now we have the solutions to fix it. So we can correct the climate, but there's going to be resistance. For one thing, a lot of us don't like change, right? We're not that comfortable with change. And the oil and gas folks have got interests not to change. So there's going to be a resistance. But I've just come to realize actually that this renewable economy, it means a life with abundant, cheap, clean energy, and jobs that are safer for the workers, safer for the planet. We're not going to have the oil spills anymore. We're not going to have the platform explosions. We're going to have bluer skies. And we can choose to correct the climate. And I think in a lot of ways we will have a cleaner planet than since about World War II. We have the ability to have, we're not going to fix all our problems, right? I mean, this isn't going to fix it. But we have the ability, and I've just really realized that we have the ability to have a cleaner planet than since about World War II, when you look at how those graphs shot up. And in a lot of ways, it's not a sacrifice. It's really an opportunity. And a lot of these products are better. We have an electric car, and I think a lot of folks, when they drive an electric car, it's better than a combustible. Not everybody's going to be happy. If you like the noise coming out of a glass pack muffler and all like that, you want the roar, you're not going to get
Or
that.
if you like the idea that you're not gonna clog out.
Yeah, well, that's getting a lot better. In other words,
I hear
yeah,
that.
no, you're exactly
I've got
right.
family who's got electric cars, I have friends who do, but right now living in Cannon Falls, I can't.
That is so true.
It's true.
It is very true, but it's very true.
We
but
didn't drive our electric car here, because
we have in the past.
Right.
We've driven, but you're right. And
But
Are you with him?
Here's the finish. Hang on here. All right.
Good girl, good girl.
Here's my fish. She's gonna come up here and we're gonna do a little dance together.
Yeah, there you go.
So I'm gonna ask you to do 3 things. One is to, with your choice, not everybody can do an electric car right now. Not everybody can have panels in their backyard or on their house. But if you don't need to idle your car or your truck, don't idle it. If insulating your house is important, and if you your food choices. I'll have a slide a little bit more with that, but with your vote, I'm not asking you to vote Libertarian or Republican or Democrat, but when you go to a primary and you've got 3 people, if you're a party person, and one of them's talking about carbon in the atmosphere, think about that. And then the last one is use your voice, and talking about climate and it isn't always the easiest to do with family, with relatives, neighbors, but talk to them, see what they're thinking, let them know. Abraham Lincoln said, public sentiment is everything. With that sentiment, nothing can fail, and without it, nothing can succeed. So, our children's world depends on it. So, that's our family. There's Amy and Casey Beth and Kate, and so I'm doing it for them. And also, so Beth and Mason got married about 4 years ago, and that's Jack, who's now 3 down here, and that's Ruthie, and this is my email, and so I'm going to ask you a couple things. So this handout is, it just shows a couple of the slides I think that's important. You know, on the one page is that natural oscillation of CO2 and, you know, that graph of carbon and temperature, and on the back, I think a couple slides that meant something, really meant something to me. So my email address is back there, and then there's a drawdown address that I'm going to talk to you a little bit about. But, you know, after seeing this, and just in talking to your neighbors and your friends or what you knew about before, if you don't realize, so this is a question, if you don't realize we've done something to the atmosphere and need to do something about it, what is it that you would need to see or know to cause you to realize we've done that? In other words, do you need to see the oceans rise 4 feet? Or do the temperatures in Cannon Falls have to be 100 degrees every day of May? What is it that would cause you to say, okay, we have done something? So, you know, when I wrap up here, let me plug this bad boy in real quick. There's so what is it that would cause you to recognize that we've done something to the atmosphere? And then also, if you need if you know of any other groups that would be, you know, interested in this information, let me know, because I'm going to do it for I think another at least 3 or 4 months. And one last thing I wanted to show you was on this handout, this project drawdown site is a really good site. It lists solutions. You can go to the site and table of solutions. It lists solutions, whether it's food waste, clean cooking, grazing, insulation, and it shows that one thing's not going to solve this. In other words, electric cars, solar panels, farming, one thing's changing our diet, one thing's not going to do it. But it shows that globally, if we do these things in combination, I won't go into it, but if you go to the site, it will, and you click on it, it'll tell you what they mean by that and how it contributes to the solution. So if you have a little time, you know, it's a really nice site.